Can you visualize a day when all these will cease to move? Movement is the key factor in a rapidly growing world, and to sustain the movement, we need fuel. The increasing use of fossil fuels all over the world today grimly reminds us of the fact that the finite reserves of such fuels may exhaust sooner than later. The challenge of excessive demand of these fuels over their limited supply has today severely hit the country's economy. The Earth's rich reserves of petroleum, a product of ancient biomass transformed over geological time under high temperature and pressure, is an independent product. The over-dependence on natural resources has led us to a situation where renewable energy has become a necessity. Energy is a critical factor in economic development of any country and is also one of the basic parameters that defines the quality of life.
The situation in India is not different. We have the necessary ingredients to produce energy. The only thing is to develop the right technology. Our scientists have been working round the clock from several years and have come out with workable solutions. Today, we will take a look at the possible ways and means by which we can utilize indigenous raw materials and fulfill our energy requirements.
The ongoing historic surge in the global benchmark crude oil rates, coupled with the depreciating rupee against the dollar and increased reliance on imports, will has pushed India's crude oil import bill higher by a whopping 42% to 125 billion or rupees 8,81,282 crore. Oil was the largest contributor to our global energy needs at 33% of total consumption, followed by coal 30%, natural gas 24%, hydroelectricity 6% and nuclear power 5%. Cumulatively, fossil fuels provide 87% of the world's energy in 2011, which was actually a tiny fraction higher than in 2010, 86.9%. If effective and forceful steps are not taken immediately, then in very near future, the human society will go back to the age of no technology system. So, the only way to sustain our economy and provide indigenously produced fuel to meet the demand is to develop alternative technologies which can provide environment-friendly solution. The government also approved the National Policy on Biofuels in June 2018. The energy policy of India is based on important factors such as rapidly growing economy with a need of dependable and reliable supply of electricity, gas and petroleum products, and indoor, urban and regional environmental impacts, necessitating the need for the adoption of cleaner fuels and cleaner technologies. The central government has laid out ambitious plans to build 175 gigawatt of renewable power generation by 2022, with the addition of 100 gigawatt of solar, 60 gigawatt of wind, 10 gigawatt of biomass and 5 gigawatt of small hydro. Biofuels are related to various government initiatives, including enhancing farmers' incomes. The government aims to develop rupees 1 trillion biofuel economy, with state-run oil marketing companies investing rupees 10,000 crores for setting up 12 second-generation biorefinery. Biofuels can help reduce import dependency on crude oil, and their contribution to a cleaner environment generate additional income for farmers and generate employment in rural areas.
It is with these goals in mind, a new initiative with the name Urja was launched. The plan was to use biotechnologies and accelerate the production of energy using indigenously developed technologies. But before that, we need to understand the definition of Urja.
The Urja has many virtues. It is conceptualized to enable every bulk waste generator to have an economically viable waste treatment solution of its own.
Urja or bioenergy is energy derived from biological sources, not from fossil fuel sources. Now, somebody will argue that a fossil fuel is also biological because they were under the earth. So we normally say that anything that has been produced as carbon in the last few years maybe 10, maybe 100, and then reused is Bio-Urja.
The Bio-Urja is 2 times faster than and twice as efficient as any other Bio-CNG system. Bio-Urja plant can coexist with people as it does not give out fumes or any smell. Hence, the problem of waste can be decentralized and tackled locally. The Department of Biotechnology has started Clean Energy and Swachh Bharat Waste to Energy as 2 of its key missions. The department has established 4 bioenergy centers in the country, specially to strengthen the research base in the country in biofuel area and to promote translation of process and technology from research to scale-up and commercialization. DBT ICT Center for Energy Biosciences, Mumbai. DBT IOC Center for Advanced Bioenergy Research, Faridabad. DBT ICGEB Center for Advanced Bioenergy Research, ICGEB, New Delhi. Pan IIT Bioenergy Center. Energy can be recovered from waste by various technologies. Combustion, in which the residual waste is burned at 850 degrees Celsius and the energy recovered as electricity or heat. Pyrolysis and gasification, where the fuel is heated with little or no oxygen to produce syngas, which can be used to generate energy or as a feedstock for producing methane, chemicals, biofuels or hydrogen. Anaerobic digestion, which uses microorganisms to convert organic waste into a methane-rich biogas that can be combusted to generate electricity and heat or converted to biomethane. This technology is most suitable for wet organic wastes or food waste. The other output is a biofertilizer. The use of these technologies in generating energy from waste has many benefits. It helps reduce its dependency on energy imports. It contributes towards reducing carbon emissions and meeting renewable energy targets. When used for electricity generation, these technologies have a steady and controllable output, sometimes referred to as providing base load power. It has very good sustainability and greenhouse gas saving characteristics, as it makes further use for materials that have already been discarded. Biofuels are produced by processing lipids by various routes such as transesterification, hydrothermal or hydroprocessing routes. Hydroprocessing of lipids such as sunflower oil, castor oil, jatropha oil, pomace oil, and waste cooking oil, either directly or co-processing with gas oil, is the more promising route for the production of aviation fuel from renewable sources.
We are running 5 major projects. On the supply side, that means to produce carbon in a fuel form, we are doing biojet, which we are producing from all kinds of oils. We are doing what's called a green diesel, which is an identical diesel to the diesel that we use in cars, which is a byproduct of biojet. We are doing classical biodiesel, but we are doing it in a distributed manner so that every village can make the biodiesel it needs for itself.
The process developed by CSIR IIP is a novel single-step catalytic process for conversion of plant-derived non-edible waste low-cost oils to produce drop-in biofuel for air transport purposes. Plant-derived oils are deoxygenated, selectively cracked and isomerized over a single catalyst to produce aviation fuel with 35 to 55% yield and with properties and compositions meeting the specification required for aviation fuel. The fuel produced in this manner has been tested and certified by leading oil companies, IOCL and HPCL, to meet Jet A1 specifications. In addition to biojet fuel, renewable drop-in high cetane diesel, 40 to 50%, is also produced as a byproduct in the process, which can be added directly in the diesel vehicles without any modifications as a cetane improver. India, being an agricultural-based country, this innovation specifically would nurture all the 3 key aspects: employment or incentives for farmers for cultivation on barren lands, industrialists can earn benefits. Environmental issues caused by petroleum-derived feedstocks. In countries like India, where the airports are near the populated areas, the SO emitted at lower altitudes by the conventional ATF renders poor air quality in the surroundings. The biojet produced from CSIR IIP single-step process has very low sulfur and particulate contaminants, making it a better fuel with lesser emissions and hence would decrease pollution levels. CSIR IIP did first biofuel flight in India, based on CSIR IIP technology for production of bio-aviation fuel on August 27, 2018. A great day for the Indian aviation industry when Indian Air Force AN-32 flew on 26 January 2019 parade with biofuel.
Another crucial factor which is causing worldwide concern is the surge in the use of plastic all over the world. The plastics are non-biodegradable and hence their increased utilization is also simultaneously resulting in increased generation of plastic wastes. The major environmental worry was how to minimize the quantity and dispose it. Scientists in India found a way to use this source to make biofuel.
The major sources of waste plastics are process industries, production industries and municipal solid wastes, with the polyolefin wastes constituting the bulk. The present methods of disposal of waste plastics like landfilling and incineration have inherent drawbacks such as turning enormous amount of land into waste and emission of toxic gases. As plastics are high-energy micromolecules and processed plastics also contain foreign materials like fillers, antioxidants and additives, a suitable process is required for conversion of waste plastics to value-added products. The process has to be environment-friendly, simple and suitable for small as well as large-scale units. CSIR, Indian Institute of Petroleum, in collaboration with GAIL India Limited, had started the laboratory-scale research work on valorization of waste plastics in 2006. The work involved screening or development of catalysts and process for converting waste plastics from different sources into value-added products.
The pre-treatment is a very integral part of this entire process. We have to shred it into smaller particles, followed by segregation as well as washing because they are very dirty and they are contaminated with some various other plastics which are not PE and PP. So segregation into PE and PP from the other different types of plastic that we do not want, washing and then finally drying, and dried plastics would be ready to be fed into the final process.
The benefits accrued from this process are: the process has the potential to solve the problem of waste plastics disposal in an economical and environmental friendly way. It can augment the supply of fuel and chemicals. The plant based on this process can be set up at various capacities ranging from 1 ton per day to larger scale.
There has been a lot of media attention about farmers burning Pirali causing air pollution. This is something which cannot be avoided. But in order to find an amicable solution, we needed scientific intervention. Scientists at CSIR IIP have developed a technology whereby this problem can be resolved.
India's economy is agro-based and has huge source of biomass availability 120 to 150 million metric tons per annum, covering agricultural and forestry residues are being burnt in open lands, causing environmental problems. These residues can be a renewable carbon resource and can be converted to energy products, chemicals and biofertilizer. In India, approximately 500 to 550 million metric tons of crop residue is generated annually, and the highest volume processed residues are sugarcane, 141 million metric ton, rice 122 million metric ton, and wheat 110 million metric ton. CSIR IIP is currently working on a mobile pyrolysis unit, supported by Aston University, UK, where a 20 kg per hour capacity truck mounted unit can be taken on-site or fields for the conversion of agricultural waste residues. This obviates the need to collect and store these residues from farmers and reduces the risk of farmers burning the stubble to plant the next crop. The bio-oil can be used as alternative furnace fuel. The byproduct biochar, 20 to 22 millijoule per kilogram, is good enough to be used for the soil enrichment, water purification and energy and heat applications.
The economic viability of the process mainly depends on the cost of the unit and also the supply chain management issues. So, to avoid these issues, the mobile unit capacity has been designed in such a way that during the seasonal gaps, the amount of the biomass which is required for the seasonal gaps can also be stored simultaneously to avoid the problems, and that same can be processed to produce. So, the capacity is designed in such a way that it will avoid those problems.
The socio-economic benefits of this technology are new income for farmers and rural population, revitalizes the retarded rural and agricultural economies, employment multiplier, activities associated with the biomass growth and collection, biomass energy systems, economic development without contributing to the greenhouse effect, local produce or waste and local applications, higher economic benefits with high value chemical products.
There are many ways to use the large amount of waste that is generated from our agricultural practices. And in order to utilize it properly, our scientists have developed new technologies. Indian scientists and the industry have come together to set up a plant that uses a homegrown technology to convert agricultural refuse into a valuable biofuel resource. It is a giant leap into becoming self-reliant in biofuel production.
Using agricultural waste as raw material, we deter farmers from burning it away. As practiced by most rice and wheat farmers, production of biofuel in turn will not only help cut down the country's oil imports, but also reduce carbon dioxide emissions into the atmosphere. The first indigenous technology has been developed for commercial production of ethanol from lignocellulosic waste by DBT ICT Centre, Mumbai. A pilot plant with a capacity of 10 tons biomass per day to produce 3,000 litre ethanol per day on a continuous basis has been set up at the IGL in Kashipur. The technology has now been transferred for commercialization to two oil manufacturing corporations, Bharat Petroleum Corporation Limited and Hindustan Petroleum Corporation Limited. Each company will set up a 400-ton plant to produce 100 lakh litres of ethanol per day by 2018. This is expected to yield 3 crore litres of ethanol per year to meet national demands. It is also capable of using a wide range of agricultural residues from sugarcane bagasse, rice and wheat straw to cotton stalk, wood chips and bamboo. It yields bioethanol in less than 24 hours, whereas other takes 4 to 5 days. Besides, it is capable of recycling 90% of enzymes and water used by the plant.
DBT ICT 2G ethanol technology is designed in such a way which can convert biomass into ethanol within 24 hours with no liquid discharge and helps in the pollution problems also. Blueprints have been designed in such a way that farmers, entrepreneurs can install such kind of small plants range between 50 tons per day to 100 tons per day in the small vicinity where biomass are available in abundance, and instead of leading into heavy logistic costs like shifting biomass to the bigger plants, it's always better to transport ethanol to the big blending stations, which will help in the Make in India concept of generating more entrepreneur, more income to the farmers.
India has a total of 500 to 550 million metric tons of agricultural waste available annually. Of this, only 15% is currently used for fodder and firewood. Even if the country can tap 50% of the total 300 million tons, nearly 100 million tons of bioethanol can be produced as against 2.65 million tons currently.
One of the most commonly used and propagated systems of producing domestic fuel has been biogas. It has been in practice from a very long time in our rural areas, fulfilling the domestic needs. But now, with a little innovation, it can be used to produce biofuel for transport sector.
Biogas typically refers to a gas produced by the biological breakdown of organic matter in the absence of oxygen. CSIR IIP have developed a process which works on the principle of absorption. CSIR IIP use porous solid media, which selects the carbon dioxide and H2S on its surface, and what you get is purified methane. Project has been developed on a lab scale in collaboration with Melbourne University, Australia. This technology is primarily targeted to be used in transportation sector. The biogas produced by this method is ideal for vehicular use. One of the most significant innovations which have been developed at the CSIR IIP Institute in Dehradun is production of fuel at room temperature. IIP becomes the first to produce in this fashion.
The basic need for the development of this technology is for the upliftment of rural person as well as to develop indigenous technology. This technology is based on the room temperature only. Other available technologies are basically based on the higher temperature. That is the boiling point of methanol. But our technology is based on room temperature. It can vary up to 5 degree to 40 degree based on the climate temperature.
In this process, all kinds of used oil are treated and recycled to meet the basic requirement of biofuel. Technically, biodiesel is vegetable oil methyl ester. The biodiesel molecules are very simple hydrocarbons containing no sulfur ring molecules or aromatics associated with fossil fuels. CSIR IIP room temperature biodiesel process is suitable for feedstocks having more than 10% free fatty acids. Biodiesel can be directly used in gensets or boilers or further purified by distillation for vehicles.
There are all kinds of ways, but contributing to and influencing directly the life of citizens is garbage generated every day in our cities. The disposal of such a huge mass is a major problem. Now, thanks to our scientists who have developed a new technology which caters to this problem, by which it can utilize garbage to produce energy.
The oldest functional landfill in the city is spread across 70 acres. The landfill contains at least 12 million tons of waste, is estimated to be at least 50 feet tall and continues to function and grow. In a path-breaking public-private partnership initiative for the East Delhi Municipal Corporation, IL&FS Environment has set up a 12-megawatt waste-to-energy plant at the Ghazipur dump site. An elaborate pre-processing system in the plant converts waste to refused derived fuel of high calorific value. Set up to initially process 1300 tons per day of municipal solid waste and generate 12 megawatt of green power. The plant will contribute to combating global warming by mitigating 8.2 million tons of greenhouse gases over the life of the project. The plant is India's first waste-to-energy, compiled Euro norms for emanation along with highest standard of pollution control measures.
We have seen different ways to produce bio-Urja. They are all viable and significant in fulfilling our country's needs. We have taken a step forward, and very soon we will be capable of producing the desired quantity and save millions of dollars for our country. Dreams are meant to be fulfilled, and once again we have proved that we are capable of finding answers to our domestic problems, and we will continue to improve. We hope you enjoyed watching our innovative technologies. In case you wish to know more, log into our website vigyanprasar.gov.in. You can also email us at ddScience@vigyanprasar.gov.in, or you can also write into us at Vigyan Prasar, A50, Institutional Area, Sector 62, Noida, Uttar Pradesh 201309.